Hi, and welcome back. So, what I want to do in this video is, I guess, to start off with, we've been talking a lot about atoms, and we've been using the periodic table a little bit for some of these videos. And I guess I realized that I haven't given you really an introduction to the periodic table and sort of talk to you a little bit about the development of it and why it looks the way it does. So I figured I'd do a video on that. So this right here that you're looking at, this is the modern periodic table. So this is the periodic table of the elements. So pretty much these are all, I guess, all the elements that you could say that, oh, I'm getting the spinning wheel again. Hopefully you could still hear me. I just got the spinning wheel for a second. These are, I guess, all the elements so far that we have discovered, I guess. So, and the way that they're arranged on the periodic table has to do a lot with the different properties that all of these different elements have. So anyway, to start off with, I guess the first thing to kind of talk about is the periodic table. Let me undo that little dot. The periodic table, the first, I guess, chemist to really come up with the idea of there being a good way of arranging the order, or a good way of or a good arrangement for the elements to go in, was Dmitri Mendeleev. So Mendeleev, and he lived, just if you were wondering, he lived from 1834, so 1834 until 1907. And he was kind of the first person, and he, I guess, is the chemist that is mainly credited with sort of the development of the modern periodic table. And essentially, what Mendeleev did, and it's important to, I guess, realize a couple of things about what he did, was he pretty much said that if the elements are ordered in a certain way based on their increasing atomic mass, so this number down here, so for hydrogen it's 1.0079, for helium it goes up to 4.0026, and we can see if we, pretty much what Mendeleev said was that if we order the elements in order of increasing mass, and we also have to do them in a certain way. So you can see that we've got sort of these blocks of elements, and it's not like we're just I guess putting them into an Excel spreadsheet or something in exact order. But if we order them in a certain way, in ascending mass order, then we notice certain traits tend to appear over and over and over again. And that the way, and really the way, pretty much what happened was Mendeleev noticed certain things, like he, particularly that, I guess elements like fluorine. So fluorine is right here. That fluorine had very similar chemical properties and would bond with other elements in very similar ways to the way that chlorine would. And chlorine's right below it. So he sort of noticed that different elements had these certain types of properties. And similarly with oxygen, would form compounds with elements and bond with elements in very similar ways that sulfur would, and sulfur is right below it. So really, I guess what Mendeleev started to notice was that there were very similar traits that elements would share, based on if you arrange them in ascending mass order. If you arranged all the elements in ascending by the ascending atomic mass, that you notice these recurring traits. And generally, the traits that he noticed, and actually I think pretty much all of the traits he noticed, all occurred in terms of these columns. So they weren't happening, and that's the other thing to realize about the period, that we have these columns. So when we say that we have columns down, like I think this is group 1A. My pen just stopped. There we go. This is group group 1A. So we have groups going down. And what we have going across are the periods. So this is period 1. This is period 2, period 3, period 4, period 5. You get the idea. So the periods go across the table, and the groups, so we have, I'll say that this is group 1A, is going down the periodic table. So we have periods going across, groups going down. And pretty much what Mendeleev noticed was that among the groups, so I guess the up and down regions of these elements. So among the groups, the traits based on what the elements, how they would bond, what their melting and boiling points were, the types of compounds they would form. When we talk more about bonding, whether they would gain electrons or lose electrons, these were all traits that Mendeleev, and actually, they're really all traits that Mendeleev noticed would repeat if you ordered the elements and in ascending by ascending mass number. One of the things that might strike you, though, because I'm saying that we order that the way Mendeleev ordered the periodic table is by ascending mass number. And you can see that the mass number, that they do go up, or they do tend to go up. So we've got 1.0079 there. We've got 4.0026 there. And we can see that our mass numbers keep going up. So there's 6, there's 9 point something, 10 point something. We see that the mass numbers keep going up, but we can also see that there are a few exceptions. Like if we look down here at tellurium, compare tellurium. It has an atomic mass, and I'm sorry that this is so small, but tellurium has an atomic mass of 127.6, and then iodine, right next to it, iodine, the mass is supposed to go up, but the mass actually goes down. Iodine's atomic mass is 126.9. So you might ask, well, that means that the modern, you might think that that means that the modern periodic table we have today isn't arranged by ascending mass. And that's true, it's not. And maybe you can see what is the periodic table arranged by today. And hopefully you can see it's arranged by the atomic number. So hydrogen is 1, helium is 2, lithium is 3, boron is 5, gallium is 31. The atomic numbers keep on going up. And actually, when Mendeleev was organizing his periodic table, he thought, again, he thought that the best way to organize it was based on the atomic mass. And really, that does make sense, and we get almost the exact same organization if we arrange by ascending atomic mass. But there are just a few places, and the tellurium and iodine is the one that I know gets pointed out most often, I think. But there are only a few places where that kind of breaks down. And even back when Mendeleev put his periodic table together, there were a few cases, and I think tellurium and iodine were one of those cases, where he didn't notice, where he was expecting to notice certain traits, and he didn't see that in the actual elements that he was observing, mainly because the way that makes, I guess, more sense, or the way that the method of arranging the elements that makes more sense is to arrange these by ascending atomic number. And so you might also ask, well, who did that? If Mendeleev didn't order his periodic table in ascending by ascending atomic number, who did? And the name of the chemist that did that was a chemist named Henry Moseley. And he lived, let me see, in case you want to know the dates, he lived from, I'm trying to look it up. I thought I had written it down. I guess I didn't. But anyway, Henry Moseley was the chemist that pretty much realized that the way that that makes more sense to arrange these elements was by ascending atomic or ascending atomic number, not by ascending atomic mass. And it's important. It is important to realize Henry Moseley does get credit for realizing that was more or less the more sensical way of ordering the periodic table. However, having any type of organization at all was Mendelev's idea. So Mendeleev is really still the chemist that gets credited with having thought up the idea that there is some really good way, like the periodic table, for representing all of the different elements. So anyway, I'm actually out of time in this video. In the next video, I'm going to talk maybe a little bit more about Mendeleev and maybe a little bit more about different traits he noticed. I'm also going to talk a little bit more about just the appearance of the periodic table and a little bit more about how you should really think about the periodic table in your chemistry class, which is really the way you should think about it is as a free chemistry department sponsored cheat sheet. So anyway, I'll leave you with that. And in the next video, we'll just keep talking about the periodic table. So thanks for watching, and I'll see you soon.